In the previous ROS video, we learned about ROS Noetic and installation and how the ROS works. Let's do a revision. As we discussed in the previous video, a topic is created and message is sent from publisher to topic. The subscriber subscribes to the topic and then receives the specific message from the data. This was all about the total flow of ROS. In this video, we will learn about creating workspaces for your project, creating packages, and then creation of nodes. So for more info, stay tuned. Let's start with building a workspace. A Catkin workspace is a place where you can build n number of Catkin packages. It's sort of a container to build n number of packages. For example, motor control package, computer vision package, etc. etc. Okay, so let's start our terminal here. And let's see what directories we have. Let's create a directory named catkin underscore ws and see what directories we have. We have created catkin ws. Let's enter into it. Right now we don't have any folders. Let's make one, which is the source folder. So now that it is created, here we have with the source. Let's build all of these packages into the source folder. So I executed catkin underscore make. So it's building the complete package. It's showing running command and build files have been written to home py catkin ws build. So it's complete. Now you can see we have various folders like build, devel and source. So basically that means that our workspace have been created. You can also see we have this in the source folder, we have this cmakelist.txt folder. So let's come outside. So this is total conclusion that our workspace have been completed. We have built an workspace for our ROS software. I'm doing that catkin.make again. You don't need to do it. We'll just enter the devel folder by cd devel, which is choose directory, and then we will source the setup file, which is the setup.bash file. There will be no output, but it's executed. Let's edit this by vim.bashrc. We'll just put this file into the start folder. So as soon as the terminal start, it will run. Okay, I don't have vim installed, so let's do it by sudo nano, the old way, and let's source it every time the terminal starts. So I'll give the path, which will be source, and I think that is catkin ws and source again. Let me check. Yes, it's okay. It's devel setup.bash, and let's do Control X and save it again. Yes, that's saved. So that file is saved, and workspace creation part is over. Let's again start with the creation of a package. So let's go into catkin ws folder. Let's enter and see what files we have, and we'll do cd source, and in the source folder we have cmake.list. you can do catkin underscore create package underscore sorry catkin underscore create underscore package, and write whatever folder basically you want to create, whatever package you want to create. For me it is my robot tutorials. And then you need to add specific libraries, dependencies, which you need to add into your ROS. So we have ROS CP and ROS Pi, which is ROS Pi, and std messages. So these are standard dependencies which we should have to run a basic ROS software. And after I do the standard messages, std underscore messages, we'll just put enter. These are libraries, and like I said before, this my robot tutorials is the name. Now let's put the enter and let's see what happens. So it shows created my file, and all these specific files have been and folders have been created. So let's see, when I do ls, I'll see cmake.list and my robot tutorials, and let's enter into the my robot tutorials pack, and you see various files and folders. Let's enter into source and do an ls. There's nothing in the source right now, nothing in source directory, so I'll come out. Let's see what's inside the cmake list.txt. So you can see that there is cmake version, my package name, and all the dependencies which I have included inside it. So yeah, and that's it. Now let's do package.xml and see what's inside. So here you can see, here we have these different dependencies again, which we have included during when we did catkin create package. Let's come outside and do again catkin make, which is building all these files together. So it will take some time as it took before, and you can see we now have our package my robot tutorials completed. We have officially created a package for ourselves. So as you can see here, we have these different packages, and then we have these nodes inside them. So the first node is camera driver, from which the data is given to the image processing node. Then that data is taken and then given to the path correction node, and then it's provided to motion planning for further purposes. And below you can see here in the motor control package that motion the motion of the driver, the motion of the motor is controlled through drivers, and then that data in loop is given back to the motion planning and path correction nodes. So this is just to explain you basically how these packages and these nodes work together, and how they give data to each other, send data to each other in order for the robot to work. Now let's enter into our catkin ws folder and enter into the source folder, and then into my robot tutorial folder. Inside that, let's create a directory name scripts by doing mkdir space scripts and enter into it by cd scripts. Now we need to create a file name myfirstnode.py using touch command. Give it some permissions. and then open it using sudo nano. Now let's do user bin environment in which it will be interpreted, Python 3 for us. And the first line will be if name equals to main, and then we'll write our code, which is first we'll name our first node, which will be my first node. So using rospy.init node, we'll be creating our first node, and then we'll be doing rospy.log info, and we'll be printing our message. So this will be basically doing what we like print function does in Python, if you're familiar with it. So we'll just do node started, and again we'll give node ends. Okay, and I just want to give delay to it, so I'll add rospy.sleep, which is sleep, and let's give it 10 seconds. No, wait, let's give it 1 second delay between each start and end. Now let's run it. So it will be Python 3 and my first node dot py. As you can see, there is some error, name rospy not defined. That's because I have not imported the rospy library, but I have called it. So import rospy, and now let's do it again. Still it is showing an error. That's because I have not started ROS core in the background, which is important while running every ROS function whenever you are starting working with ROS. So I've started ROS core, and then you can see the node started and ended is showing. Let's run it again. You can see, yeah, that's how it works. Now let's edit that file again, and let's do it so that we get continuous prints of something. Maybe node ends will be printing continuously within a loop. So I'll just open this file and I'll make some changes here. I'll give a rate, just rospy.rate 10. And I'll give if rospy.is is not shut down, if it's not, so it will keep continuing. And I'll just add rospy.rate again here. I'll just call it rate.sleep here without any argument, because we've already given it. And node ends will be printing. So what this basically will do is it will continue printing node ends until I cancel it. So yeah, I've pressed Ctrl Z and I have stopped it. So you can stop it by giving external command. So that's how we've created our first node. Now let's see on rosnode.list if our node is available. You can see it's available, my first node.py. Before it will be not available, but after I start ROS core, it will be like, and run my program, it will be available again. Now when I do it, I'll see my first node. So that's it with the part of node creation. So that's it for the video, guys. If you like this video, make sure to hit the like button and subscribe to our channel. In the next video, we'll be doing more things regarding ROS, like publishers, subscribers, and we'll be attaching a leader to it as we promised in the previous video. So that's it. Stay safe, stay tuned at Robu.in.